Hey guys, so if you are a power engineer and you have a complex circuit that has a lot of voltage sources, current sources, dependable current sources, and you have a complex circuit like this, and you need to find the current that is flowing through a resistor or a component and the voltage that is measured across it in a complex circuit, you would use Kirchoff's current law or Kirchoff's voltage law. So that is why it is so important to learn these. Because what is going to happen otherwise is, if you do not know the current or voltage that is flowing across a component, you cannot find the right component with the right rating, and if you put the wrong component in, that is just going to blow up, and you do not want that. So let us go ahead and learn what KCl is first. So KCl is basically the law of conservation of charge. So if you have a node is basically where a bunch of connections, electrical connections, come together. So according to KCl, the sum of currents entering the node is equal to the sum of currents leaving the node. So is this? All right. So if you have a circuit, something like this, right? If you have a node, so this is going to be my node, and I have three currents, I1, I2, and I3. So just by visual examination, you can tell the current entering the node. So this is going to be my node, and the current entering my node here is I1, and my currents leaving the node is I2 and I3. So I can write my expression for KCl as I1 is equal to I2 plus I3. So that is my KCl expression. So KCl is very easy to understand. You have currents entering the node and you have currents leaving the node. So the currents entering the node is equal to the sum of currents leaving the node. All right. Now let's go ahead and understand KVL or Kirchoff's voltage law, which is law of conservation of energy. So if you have heard the basic theory about energy, conservation of energy, that is, energy can neither be created nor destroyed. So the same thing can be modified and applied to a circuit. So if you have a circuit that's somewhat like this, and you got the power in the circuit is supplied by V, and you have two resistors. So if you just look at it, the power to the circuit is energy supplied by this power source, V, and the energy is dissipated by these two resistors. So according to Kirchoff's voltage law, the algebraic sum, or just the energy supplied, is equal to the energy dissipated. So the energy dissipated would be the voltage drop here. So that would be I times R1 plus I times R2. So the energy is supplied and the energy is dissipated. If you have another voltage source here in the opposite direction, let's call this V1 and V2. So then this expression would change, because now you have energy being supplied by two sources here. So it would be, since they are in opposite direction, V1 minus V2, whichever one is higher. So just the difference in that. All right, so that is Kirchoff's voltage law. Now let us go ahead and solve a few example problems that you might face while taking the fundamentals of engineering exam. So I got a circuit right here. It's going to be, I got a 3 kilo ohm resistor in parallel with a 10 milliampere current source in parallel with a 4 kilo ohm resistor that is also in parallel with 10 kilo ohm resistor. All right. The question is, what is the voltage across this 10 kilo ohm resistor. So if you hooked up a voltmeter or a multimeter across the 10 kilo ohm resistor, what is the voltage that would be measured? And also this junction is grounded. So if you look at this circuit, all the ends of the resistors are shorted or connected together. Right? So in reality, this circuit would look somewhat like you got your 3 kilo ohm resistor, you got your current source, and you got your 4 kilo ohm resistor, and you got your 10 kilo ohm resistor. Right? So one side is completely grounded. All right. So if you remember your Ohm's laws and all the basic principles, the voltage or the potential difference across different branches in a parallel circuit is the same. So if you measure the voltage across the 10 kilo ohms or the 4 kilo ohms or the 3 kilo ohms, you're basically measuring the voltage across these two junctions, which are just shorted. So it's going to be the same voltage that you measure across. All right. So something about series and parallel circuits, which you also be going to look into. So if you apply, we're going to apply Kirchoff's current law to solve this, and I'm going to show you how. So first, let's consider this node, all right? And you got one branch, current coming through this branch, the 3 kilo ohm branch, and since all these ends are shorted, I'm just going to put this as V. So I'm going to consider this as the potential of V volts, and all of these ends are shorted and got ground here, which is going to be 0 volts. All right. So I have my current coming in through the 3 kilo ohm resistor. So if you just use Ohm's law, I is V by R. So I got V minus 0 by R 3 kilo ohms. All right. And then I got my current coming in through the 10 milliampere current source, which is just going to be 10 milliamperes. And then I got my current coming in through the 4 kilo ohm source, which is going to be V minus 0 by 4. Then I got my current coming through the 10 kilo ohm resistor. That's going to be V minus 0 by 10. Since the other side is grounded, the charges are just going to be dissipated. So there's going to be no current leaving the mesh. And this is going to be 0. All right. So if you solve this equation, you're going to find V. It is as simple as that, right? So in order to solve this, I'm just going to take V, which is common here. So V times 1 by 3 from this, 1 by 4 from this branch, plus 1 by 10 from the final branch. And if I move the 10 milliamperes to the other side, I get minus 10 milliamperes, right? So my V, if I solve for this, I would get V times 3 inverse plus 4 inverse plus 10 inverse is 0.68. All right, so is equal to minus 10 milliamperes. So your V would be minus 10 milliamperes divided by 0.68. Which would be 14.63 volts minus. So that is your final answer. If you hooked up a voltmeter and you measure the voltage, you would get minus 14.63 volts. So the minus sign just means you gotta flip the terminal. So we consider this to be at a higher potential than the ground, But if you actually measured the value here, it would be reverse. So this V would be at a lower potential than the ground. So hence it would read a potential of 14.63 volts below ground. So that is your final answer.